You ever get that feeling like the world of computing is just accelerating so fast, you're kind of just trying to hold on?
Oh, absolutely. 1 minute, it's processing speeds. The next, yeah, AI models with billions of parameters.
It really can feel like drinking from a fire hose.
Totally.
Well, that's exactly why we do the deep dive. We're here to, cut through all that noise and get to the signal, the really important shift.
Precisely. We wade through the dense stuff, the research papers, the keynotes, the transcripts to pull out those core insights, those aha moments for you.
And today, we've got a perfect source for that.
Yeah.
The official transcript from NVIDIA CEO Jensen Huang's COMPUTEX 2025 keynote.
Yeah, this wasn't just about faster chips. He laid out, well, a whole new landscape, really.
So our mission for this deep dive,
Mm-hmm.
unpack the key takeaways from that keynote. What are the big shifts in computing, AI infrastructure, and robotics that you really need to know about?
Let's get into it.
Okay, let's dive in. Huang kind of starts by looking back, right?
Mm-hmm.
NVIDIA's 30-year journey. It's almost hard to remember they started mainly as a graphics chip company.
It is, isn't it? And he really stressed this constant reinvention, leading to where they are now, what he calls an AI infrastructure company.
Right.
He pointed to a couple of moments. CDA, back in 2006, that was huge for parallel processing.
Yeah, foundational.
And then around 2016, this realization that, okay, a totally new computing approach was needed. It meant rethinking the entire stack.
And led to the DGX-1, yeah. He even mentioned giving the very first one to OpenAI.
Mm-hmm.
And here's where it gets really interesting. That single act, it feels like it planted the seed for this massive AI explosion we're in now.
It's a great origin story he tells, that DGX-1 donation as the spark.
Yeah.
And then he explained how AI workloads shifted things away from traditional hyperscale computing, where you had a few big processors doing lots of different things,
Mm-hmm.
to a model needing intense east-west communication. Think lots of specialized processors needing to talk to each other constantly for these big AI problems.
Oh, yeah. Okay, so horizontal scaling, basically.
Exactly. And that insight, well, naturally, that led them to buy Mellanox, the networking specialists.
Right, because certainly the network pipes became just as vital as the chips themselves.
Absolutely critical.
And this gets us to a pretty fundamental change in thinking, doesn't it? This idea of the data center as a unit of computing. That's a big mental shift.
It really is. He's arguing the basic unit isn't your laptop or even one server anymore. It's the whole data center working together on maybe just one massive task.
Wow.
Which, has huge implications for things like the operating system, a challenge they're clearly tackling.
And then we got something really unusual for tech, a 5-year roadmap just laid out there. That's like showing your poker hand before the betting starts. Why so transparent?
His reasoning was interesting. He framed NVIDIA as an essential infrastructure company.
Okay.
Like early electricity grids or the internet. These things needed long-term planning across industries.
Right, coordination.
So by giving this long view, NVIDIA lets partners plan their own huge investments power, cooling, buildings, knowing where the tech is headed. It's about de-risking it for everyone.
So it really changes their role, not just selling chips, but building the foundation for, a global intelligence grid.
Something like that. And this grid needs factories, these AI data centers that produce tokens.
Tokens. It's a very industrial way of looking at AI output. What does that mean, thinking about intelligence that way?
It's a very deliberate analogy, I think. AI factories, they consume energy, they output tokens, the results from AI models.
Uh-huh.
He even suggested we might track token production rates like factory output soon. It really frames AI not just as research, but as large-scale production.
Okay, so we've got this reinvented computing foundation. The core tech powering these factories. Huang keeps hitting this fusion of accelerated computing and AI, but also libraries, pseudo-X libraries. Why are they so important?
Right, this is key to their whole strategy. The chips get the headlines, but he kept stressing these CDA-X libraries are their secret sauce, their competitive moat.
Okay.
They're super optimized software packages for specific tasks across tons of fields, all using their GPU parallel processing.
Right.
He even said they're maybe unique in how much they focus on libraries, because that's what unlocks the hardware's power for developers. It creates this whole ecosystem that's really hard to copy quickly.
And he showed that with the RTX 5060 demo, didn't he? The
Yeah.
real-time ray tracing where AI guesses most of the pixels.
Yeah, that was visually stunning.
Huh.
DLSS neural rendering guessing what, 9 out of 10 pixels? It shows how tied together AI and graphics are now. And he did mention the successful RTX 50 series launch. PC gaming is still vital for them, driving a lot of tech innovation.
But these libraries, they go way beyond graphics. The scope is just huge. COMPUTEX for numerics, Aerial for 5G, 6G signal processing.
Genomics with PARS, medical imaging with MONAI, Earth-2 for weather, even quantum for quantum computing.
It's like this massive toolkit for any heavy computation.
Exactly. And there were more. Qtensor, the whole deep learning stack, CUA, CoDNN, Megatron, Tensor, LLM, even Dynamo, which he called an OS for AI factories.
An OS for AI factories. Wow.
Yeah, QDF for data frames, QML for classical machine learning, Warp to make CDA Python friendly, QOpt for optimization, Cutus Scus for engineering sims.
And Coolitho, used by TSMC and ASML for making the chips themselves.
Right. That breadth just shows how deeply embedded they are everywhere.
It's almost overwhelming, but the point is, these aren't just niche tools. They're accelerating everything, opening up totally new markets.
Speaking of new markets, telecommunications and quantum computing got a lot of focus.
What's the play there?
Well, in telco, the big shift is software-defined RAN radio access networks. NVIDIA spent 6 years building an accelerated RAN stack that, he says, now matches specialized hardware performance.
Okay, so it competes.
Competes, yeah. And the key is, once it's software, you can layer AI onto 5G, onto 6G networks. He mentioned partners like SoftBank, T-Mobile, Nokia, so it's happening.
And quantum. Still early days, right? What do you call the ICE-Q era?
Right, noisy intermediate scale quantum. But they're already building a platform, see you at Q, for quantum classical hybrid computing.
Hybrid.
Yeah, the idea is future supercomputers will have quantum accelerators alongside GPUs. The GPUs might handle error correction, control, pre-processing, complementing the quantum part. It's a pragmatic approach for now.
Okay. Now let's talk about AI itself. We went from perception AI to generative AI, and now he's talking agentic AI and physical AI. What's the difference? Why should we care?
This is a really important evolution. Perception AI understands stuff, images, speech. Generative AI creates new stuff, text, images, video, like a universal approximator.
Got it.
Agentic AI is the next step. It can understand a goal, reason about the steps, use tools, even work with other AIs. He called them digital robots.
Digital robots.
Right.
Potentially addressing labor shortages. That's a big claim.
It is. And then physical AI is even more advanced. It understands the physical world, gravity, inertia, object permanence.
Like physics.
Yeah, basically. The example was AI generating realistic videos to train self-driving cars in tricky situations it hasn't seen. It's like it intuits the physics to create its own training data.
Whoa, that capability is crucial for real autonomous systems, robots, cars.
Exactly. It overcomes the massive cost and difficulty of getting enough real-world training data.
Okay, this all feels like it's building towards something huge, and then, boom, Grace Blackwell. Positioned as the next revolution specifically for inference timescaling, enabling thinking AI. What's the deal?
Grace Blackwell is a massive infrastructure leap. He distinguished between scaling up bigger computer and scaling out more computers. Blackwell pushes scaling up massively within one node.
Okay.
The upcoming GB300 version, 1.5x inference performance, 1.5x more HBM memory, 2x the networking, all in the same physical box as the B200.
The performance numbers are just wild. A single GB300 node having the power of the 2018 Sierra supercomputer.
A 4,000x increase in 6 years. It really hammers home the exponential curve we're on.
How do they even connect it all?
That's where NVLink comes in. Their super fast interconnect, connecting 72 GPUs in one rack, getting 130 terabytes per second bandwidth.
Which is more than the entire internet's peak traffic, seriously.
Yeah, that's what he said. And the power density, 120 kilowatts a rack, forces the move to liquid cooling. These things are intense.
And these aren't just single racks. He showed AI factories with CoreWeave, Oracle Cloud, xAI. Their Colossus is 4 million square feet, pulling a gigawatt.
Yeah, the scale is astronomical. And the anecdote about trillions being invested in this infrastructure, it's not incremental, it's a fundamental reshaping.
Trillions, wow.
And he gave props to the manufacturing miracle behind it, TSMC making chips with 200 billion transistors, the global effort with Foxconn, Cooler Master, showed a whole video about it.
And then the big news, NVIDIA partnering with Foxconn, Taiwan's government. TSMC to build a giant AI supercomputer right there in Taiwan. NVIDIA Constellation at Baithun Shieling.
Huge commitment to the region, underscores Taiwan's role. He also introduced NVLink Fusion. This allows others to plug their own custom chips, ASICs, CPUs from partners like L-Chip, Astera Labs, MediaTek, Fujitsu, Qualcomm into the NVIDIA ecosystem. More flexibility.
Okay, so that covers a massive scale.
Mm-hmm.
But they also announced things for, like, individuals and regular companies. DGX Spark and Station?
Exactly. DGX Spark is pitched as a personal AI supercomputer for developers. 1 petaflop, 128 GB HBM, powerful tool for prototyping. Tiny compared to the original DGX one.
And available through Dell, HPI, Lenovo, much wider reach.
Right. Then DGX Station desk side plugs into the wall but can run a trillion parameter model. That's insane workstation power.
Again, available through similar partners, plus specialists like Box, Lambda. It really feels like they're trying to get this power out there.
It's definitely democratizing access. And then there's the RTX Pro Enterprise and Omniverse server. This one's aimed squarely at bringing AI into traditional enterprise IT.
So bridging the gap.
Well, it's built on standard by 86, supports hypervisors, Kubernetes, Citrix streaming, integrates more easily into existing setups. The goal is to enable those digital workers, the agentic AI, within normal businesses.
And the performance.
He showed charts claiming like 4x the throughput of the previous generation on big language models. So serious performance for enterprise AI tasks.
But compute is only half the battle, right? You need the data. So the enterprise AI data platform and AI ops.
Exactly. Traditional storage isn't great for the unstructured data AI thrives on, so their AI data platform uses AIQ NVIDIA AI Query. It's GPU accelerated and understands semantic meaning in data.
Using that Llama Neutron model. Faster retrieval, better results.
That's the claim. And they're working with storage vendors, VAST, Dell, Hitachi, IBM, NetApp to integrate it. The VAST demo of a sales research agent building a plan in minutes instead of days was pretty compelling.
Yeah, that showed the practical business value.
And AI ops is the management layer for all this in the enterprise data curation, model tuning, security, monitoring. Partnering with folks like CrowdStrike, Dataiku, Red Hat, Nutanix, building the whole ecosystem.
Okay, finally, robotics and Omniverse.
Yeah.
All this compute and AI seems to be leading towards smarter physical machines. Starts with virtual training worlds.
And critical first step, yeah. Can't really train complex robots safely and efficiently just in the real world. Need good simulation. Their Newton physics engine built with Google DeepMind, Disney Research, going open sources for that, high-fidelity physics on GPUs, integrated into Muchoco and Isaac Sim.
Which powers the Isaac GR00T platform, Jensen Thorchep, Isaac OS, pre-trained models.
Right, and Isaac GR00T N1.5 is open source, getting thousands of downloads already. Shows the interest.
And tackling the data problem for robots. How do they get enough training material?
That's where AI amplifying human demos comes in the GR00T Dreams blueprint. Robots learn more with less manual input using synthetic data generated by these Cosmos physical AI foundation models. Huge time saver.
The humanoid robot potential for labor shortages keeps coming up. He thinks multi-trillion-dollar industry.
He does.
Yeah.
Because of the sheer scale needed. And Omniverse is the key enabler here, creating digital twins of factories.
He mentioned $5 trillion in new plants being planned globally.
Incredible number. Companies like Delta, Foxconn, TSMC are using digital twins to design layouts, optimize workflow, train robots virtually, manage fleets.
Even simulating entire cities like Goshen.
Yeah, with Linker Vision. Omniverse is that bridge between virtual design, simulation, and controlling the physical systems. It's foundational for these future intelligent systems.
So stepping back from the whole keynote, the big picture is this huge wave of transformation driven by AI, right? It's remaking computing infrastructure, changing how businesses work with digital agents, and bringing us towards, well, useful robots.
And it's all interconnected. Better hardware enables smarter AI, which needs better software tools and libraries, which pushes hardware further. It's this constant cycle.
This deep dive definitely gives you a lot to chew on. Thinking of these AI factories, digital workers, advanced robots, what new possibilities, maybe new challenges too, might pop up in your world? Your daily life soon. Something to mull over for sure.